Okay, hi everyone. I hope this video finds you well. So today we are talking about the fetch, decode, execute cycle. The first thing we are going to talk about is the bomb. This is electromechanical device that some see as a fixed program computer that helped win the World War II. So basically, this is the device the British used to decipher the Enigma code, and that helped them win World War II. So, von Neumann architecture. So, if you want a bonus points, write about 10 lines about who is von Neumann on Canvas. So, the earliest computing machine had fixed programs. Some very simple computers still use this design either for simplicity or for training purposes. For example, the disk calculator on your disk, the calculator you use on your disk for math, basically this is a fixed program computer because you cannot make this calculator do anything other than calculating. So von Neumann designed a way to store programs in the same memory that data was stored on. So basically, this allowed for updatable programs and loading new programs into the same memory. And that was amazing because this is basically the essence of what we have today in our hands, the computers that we know today. So what is program? So the CPU reads instructions written in machine language called an instruction set. Each instruction is represented by a unique number. Usually that would be a binary number. So a program is composed of a list of those numbers, what we call opcodes. The compiler creates this listing based on the code in the source files. So here's an example of instruction set. As you can see, the number and what the number means. So for example, 0001, that means move, 0010, compare, bit set, bit clear, and so on. So the machine instruction is an instruction or command encoded as a bit pattern recognizable by the CPU. Machine language, on the other hand, is the set of all instructions recognized by a machine, the CPU, recognized by the CPU, because the CPU is the brain of the machine. So how a program runs? The program is copied into RAM and set up as a running process. So what do you think does this mean? Or which program is doing this? Copying the program into RAM and setting up the program as a running process. Remember the loader? The loader does that. Okay, so the CPU will then execute the instructions. The CPU uses the instruction cycle for processing these instructions. And this is the cycle we are going to talk about today. The instruction cycle, which we call the fetch, decode, and execute cycle. So nearly all CPUs follow the fetch, decode, execute cycle. So basically, the fetch, decode, execute are collectively known as the instruction cycle. We will not be directly programming these machine instructions, but it's vital to understand the connection between your code and these instructions. So the instruction cycle is consisting of three things, as we said. The fetch step. So fetch means read the instruction from the memory. The decode decodes the instruction to determine how to perform the operation, what the instruction means. The execute actually performs the operation. Just do it. So you fetch the instruction, you decoded the instruction, and now you know what to do with it, and now it's the time to do it. So the CPU register. A processor register, or what we call CPU register, is one of the small set of data holding places that are part of the computer processor. A register may hold an instruction, storage address, or any kind of data, such as like a number or individual characters. Some instructions specify registers as part of the instruction. So here's what we are going to deal with today. This chart. Let's see how we load the CPU with the instruction and how to decode it and eventually how to execute it. So we have two buses. The first one, the second one. The first one is the data bus, and the value to be read or written to or from the RAM is sent on the data bus. But where that data was stored is what is being located on the address bus. So the address bus, what location in RAM to read or to write to read from or to write to, is specified by a memory address on the address bus. So the first thing in this process is setting the address on the address bus. Then the memory is we are going to look in the memory and fetch the data in that address, located in that address, and put it on the data bus. Then we are going to continue the steps as we are going to see in this lecture. So the fetch. So address 1 is used to tell what item from RAM is to put on the data bus. So the first thing you're going to deal with is the program counter. The program counter is basically setting what address to access in the memory. So this is done by sending it to the address bus. So as we set the address on the address bus, immediately, the program counter is incremented. So we put the second address. But we are still processing address 1. So first thing you do is you set the first address on the address bus, then immediately put the second address on the program counter. So the program counter is incremented, so the new data is going to be fetched after we complete the process, after we complete the address 1 instruction process. Okay, so as we deal with the data and the instruction of the address 1 that is located in address 1, we set up the program counter to prepare for the next cycle. Okay, so the instruction right now is being fetched, retrieved, and placed on the instruction register. So the instruction that was located, let's say that was address 1, and the instruction on that memory address is going to be put on the data bus. After that, the data bus is going to move it into the instruction register. So that is happening because what we have on the address bus is address 1. So as long as we have address on the address bus, the instruction cycle is going to work. So after we fetch that and put it into the instruction register, we are going to decode. So usually the decoder is part of the control unit. But because we want to separate them for illustration purposes, we are going to have them both separated in here. But they are usually one unit. Okay, So the decoder determines what the instruction means and set up the CPU up to that to do the instruction. So the decoder says, okay, this is what the instruction means, looking at the opcode and the operand and all these things. Then telling the control unit what to do with the ALU, the arithmetic logical unit, which is basically the heart of the CPU that does the calculation, which is going to do the execution. So the control unit tells the arithmetic logic unit what to do based on the instruction, and the ALU is going to execute it. After the execution, we have a result. The result is going to be stored in one of these registers. Then, after that, when we are done, we are going to start the cycle over with the next address. This address is going to be moved into the address bus, and immediately that is going to be incremented to address 3, and then fetching that into data bus putting that into instruction register. Then the decoder decodes it, tells the control unit what to tell the ALU to do. The ALU does it, execute it, and then store the address in the register. And that is all of it. So let's now dig deeper into this cycle and explain everything in a little bit of details. So fetching the instruction. So the next instruction is fetched from the memory address that is currently stored in the program counter, the PC. It's copied into the instruction register. Eventually, after the fetching is complete, we put it into the instruction register, as we have seen. At the end of the fetch operation, the PC points to the next instruction that will be read at the next cycle. Remember that? We immediately increment the address in the program counter as we fetch. Then the decode. So the instruction decoder will translate the value in the instruction register based on the instruction set of the CPU, which we call instruction set architecture, ISA. So different CPUs have different instruction sets. So often the instruction has two parts, the opcode and the operand. The opcode, which indicates which operation is to be performed, addition, subtraction, multiplication, and so on. The operand, which can provide supplemental information required for the operation. The decoder will set up the CPU to perform the instruction by the help of the control unit. It converts the instruction into signals that control other parts of the CPU so they will do the specific instruction. So decoding the instruction. During this cycle or during this step, encoded instruction present in the IR, the instruction register, is interpreted by the decoder. The decoder then process allows the CPU to determine what instruction is to be performed so that the CPU can tell how many operands it needs to fetch in order to perform the instruction. I'll give you the example. If we have add, if the operand is, if the opcode is add, or means add. So you need two operands. You need X and Y, or add 1 and 2, 1 plus 2, and so on, right? But if the opcode means negate, then you need only one operand, X. If X was 5, it becomes -5, right? So the opcode fetched from the memory is decoded for the next steps and moved to the appropriate registers. The decoding is done by the CPU's control unit. Okay, the execute step, which is just do it. So after the fetch and decode steps, the execute step is performed. Depending on the CPU architecture, this may consist of a single action or sequence of actions, depending on what the instruction means. During each action, various parts of the CPU are electrically connected so they can perform all or part of the desired operation, and then the action is completed, typically in response to a clock pulse. So basically, when we say such thing, if you have 2.5 gigahertz CPU, then basically the instruction is going to be executed in 2.5, or roughly 2.5 nanoseconds. And this is the clock pulse. So very often the results are written into the internal CPU register for quick access by subsequent instructions. In other cases, results may be written to slower but less expensive and higher capacity main memory. So simplified fetch, decode, execute cycle. So the following example about the instruction cycle is designed to give you a general idea of what happens in the fetch, decode, execute cycle. However, note that this is not exactly how it works, but basically is sufficiently enough and sufficiently accurate for our purposes, which is for you to understand how this works. But this is not exactly how that works. So we are going to deal with the RAM, and we will use the simplified CPU instruction set, like 0 means add, 1 means subtract, 2 means multiply, 3 means divide. And the division we are going to do is the simplified division. So for example, if you have 3 divided by 2, the answer to that is 1. Why? Because we truncate anything after the decimal point. So the actual result is 1.5, and we remove anything after the decimal point, so we end up with just the 1. 2 divided by 3 is 0, because that is 0.67, so we remove everything after the point, we end up with a 0. Okay. So we are going to have a program instructions like these. So the loader is going to set up the RAM, right? Set up the RAM. It's going to do that exactly like this. The first instruction in the first location, the second in the second location, the third in the third location, and so on. And you may want to have the word end after you're done loading all the instructions. If you want, this is optional. So once you do that, once you loaded the program into the RAM, you immediately put the location, the address of the first instruction. So the address is 1001, which is basically this one. Immediately. This is the loading process. So now it's ready to run, right? So the fetch, the first step will be to get the instructions from RAM. The program counter holds the location of the next instruction. It will be brought across the data bus. The data bus is just a set of wires that will allow the data to go from RAM to the CPU. So we are getting the value in 101, which is this, the 101. So we are going to put that into the instruction register. So putting that into the instruction register, the instruction goes into the instruction register. Then we are going to immediately update the program counter and increment it by 1. So we incremented the program counter. And then we are going to decode. So the instruction decoder will translate the value of the instruction in the instruction register based on the instruction sets of the CPU. So we may have opcode and more than one operand or just one operand. So let's now decode. So let's take a look at the instruction set. And we start from the left. The first number, as you can follow this instruction format, the first digit is going to be the instruction, which is basically this. And we have operand 1 and operand 2 for the other 2 digits. So 1, this digit, is subtract. So we have subtract and we have 0, 1. Subtract 0 and 1. So 0, 1, and we do that again from left to right. 0, 1, and the operation is the subtract. So once we know what that means, we set it up in here. We say minus. Then register 1 and register 2. What do they contain? 0 and 1, the other 2 digits. Then execute. You're going to do it. Perform the action. Perform 0 minus 1, which is basically negative 1. Negative 1 is the current output. If you want to save it, you put it there. You save it in the saved output. Now, after that, we are done. We save the output. The cycle is finished. So we start a new cycle with the program counter 1002. So the cycle now repeat with the new value of a new address in the program counter. So the program counter was 1002. Go there, fetch that. That was 205. You put it 205, right? Then the 205 decode it. What is 2? 2 means multiply. So, and we have 0 and 5. Then after that, you execute. You decode it. Now you execute. 0 times 5, 0. And you save it. You have 0. And that's it. So once you do that, remember, when we do that, we have 1002, we look it up, we move the 205, immediately increment this one. Don't forget to do it. So that becomes 1003. Before you even figure out what is the first digit in there means. So instruction goes into the instruction register and we immediately increment the program counter. That means multiplication. The 2 means multiplication. And we have 0 and 5. 0 times 5, the execution is 0. Then we save that in there. Usually I prefer if you have commas. So again, we bring what in 1003. That is 302. Then don't forget to immediately increment this one. And continue the example. So what I'm going to show you is the exercise worksheet. So I have it open in here and we are going to try with another example. So the first example is going to be a program of 5 instructions: 050, 141, 3232, 323, 112. Here's the instruction format. We are going to follow that for the whole quarter. And this is the instruction set. And this is the RAM we are going to load. So you must load the RAM. The first thing you do is you load the RAM and set up the program counter, right? The initial program counter. So you complete that. So let's see the completion of this. So basically we loaded the counter. So we have this, the 050 as the first instruction, and then we have 141, and then we have 232, then we have 323, 112, and as I said, if you want, you can use end. Let me just remove all these. Okay, now we have it loaded. And let's start working on the fetch, decode, execute cycle. So 050 after we fetched what's in the 1001, and immediately increment the program counter on the same line in the fetch, right? In the fetch cycle, on the fetch step, you increment the program counter. Then you decode the 0. What does the 0 mean? And the 0 means add. So add. Then 5 and 0, the two operands, and 5 plus 0, 5, and you save the output. Then next, bring what's in 1002. That was 141. And immediately increment the program counter. Decode, that is minus, subtraction, and 4, 1, the 4 and the 1 from there. 4 minus 1, that is 3. So 5, we put the 5 again, then comma 3, and so on for the whole part. Okay, there is another example of 6 instructions: 201, 321, 013, 126, 222, 191, and the instruction format is the same. The instruction set is the same. We load the memory. And after we loaded the memory with 201, 321, and again, this end is optional. If you want it, you can have it in there. If you don't want it, it's okay, as long as you load the memory, because this is the important first step. And then the initial is going to be 101, and let's fetch in 101. What's in 101? That was 201. The instruction was 201. So 201, immediately increment the program counter. Decode what the 2 means, the first digit. The 2 is multiplication. So multiplication 0, 1, this is 0. We save the 0. The next fetch is what's in 1002. That was 321. Increment the counter immediately. 3 is divide. And as you can see, we have 2 divided by 1, which is 2. And the result is 0 and 2. And you continue working on that. Just to make sure that you understand that if we have something like this, division and 2, and this is in the first example. If we have division, 2 and 3, 2 divided by 3 gives us 0, because we truncate everything after the decimal point. Just to make sure that you understand that. So you fill it out, and the key points. Now, the key points of this lecture is the idea of storing instruction in the same memory as the data allowed us to create programs that could be updated easily. This moved away from the fixed program computer, like the calculator on your desk, right? We could load new programs into memory. They no longer had to switch hardware components to manually change the connections so they get to make a new program. They no longer had to do that. Once the fetch of the instruction is complete, the program counter increase to the next instruction. And this is one of the most important things you should know about the fetch, decode, execute cycle, because if you forget to do that, then the cycle is disrupted and broken. So another set of key points: a program is comprised of many instructions in the machine language. A program will be copied into memory for the CPU to execute. The CPU uses fetch, decode, execute cycle, and you should understand and memorize what fetch, decode, execute mean. So fetch reads a signal, a single instruction from main memory to the instruction register. Decode, the control unit, part of the CPU, decodes the instruction that were just read from the main memory to determine how to perform the instruction. This is the key statement in this definition. And execute, now that the control unit has determined what the instruction indicates should be done, the operation is performed. So operation is performed, or just do it. So explanation homework: explain the fetch, decode, execute cycle to 2 different people. Be sure to discuss why it was an important development, and bring the name of von Neumann and why he was critical to this process. So I left to you the goals of the explain assignments, as we explained in the other lectures, the steps in assignments to explain, why the spacing between the explanation is important, the 2009 Cornell study of the spacing, why does mixing up subjects matter, help the learning process, importance of self-assessment, and that's it for the lecture. But we are not done, because I set up this Excel sheet. Here is the instruction set. Here is the instruction format, and you fill out this one. You fill out these places with the program instructions in here. And then I did the first one, 111101002, updated the program counter, fetched the first program, this one after I loaded that, updated the program counter, that was 1 and 1, and the operation was subtraction based on the first digit in here. And 1 minus 1, that is 0, and this is 0. The next one is bringing the second instruction, which is 045. Update that to 1003. Then that is 4, 5, and the 0 means addition. This is 9, 0, 9, and so on. You complete this one, upload it to Canvas. So after you complete the Excel sheet, save it, and save it as. So save as. For example, let's say I'm going to save it in here. Then after save as, after that I'm going to keep the same name, but I would add my name. And you add yours. You add yours. This is the student name, and save. So let's go see where you should upload that. So you should be uploading that to the activity fetch, decode, execute worksheet. Here you can upload it. So the solution to that worksheet is going to be uploaded immediately after the due date. Immediately after the due date. That's it. Have a great day. See you in the next one.